Welcome to it, ladies and gentlemen. Thank you again for joining us. Today we're looking at linear graphs, and we stated last time when we looked at the basic graphs that the basic equation for a linear graph is y equals to x. Everything else that we see, the expanded form, which I'm just going to write on the side here, is really just a transformation of the y equals to x graph. And how did this happen? So we have that f of x is equals to x. The first transformation that we have there is going to be, it can even be inside or outside of the bracket. But if you think about it, we can have it like this will give us mx, right? And then we then have, we're now adding a term c to it, which gives us mx plus c to it, okay? So these are two transformations where the first one is really just a stretch, okay, where we divide x coordinates by m, okay? And then the second one is really just a, because it's outside of the bracket, it's going to be a translation, okay, of c units along the y. Now, why do we say it's along the y? Because it depends on the nature of c. If c is positive, then it moves up. If it's negative, then it moves down, okay? Right. So coming now to the effects that this have as well. I need you to understand something. You can be able to tell that an equation is linear or will give you a straight line graph just by looking at the nature of the x. Okay, you'll notice that the power of the x is 1 there. This one tells you that there's only that it actually crosses the y-axis once. Sorry, the x-axis once. What else? That there's only one solution if you resolve it. Okay, and all these things are true. So for us to be able to identify a straight line uniquely, we need to look at those two here, okay? So that's what we're going to be looking at today. So understand that the nature of m, if m is positive, then our graph will be looking upwards, like that, okay? It's looking upwards. That's the nature of our graph. And if your m is negative, then our graph will be looking downwards like that. So the idea is to move from left to right. So if it's positive, it means that as you move from left to right, your graph is going to be moving upwards. But if it's negative, then it means that as you move from left to right, your graph is going to be looking downwards, okay? And then we all know what the c is. So the c also tells us the y-intercept, okay? And the y-intercept, ladies and gentlemen, is going to be where the graph crosses the y-axis, okay? And the m tells us about the slope, which is what we just looked at right there, okay? So let's look at 4 graphs that will help us to understand what is going on, okay? M is positive, C is positive. What kind of graph do we get? So if M is positive, it means it's looking upwards, but at the same time it's cutting Y where it's positive, which means that it's supposed to cut Y above the x-axis, okay? And the next one, M is positive, but C is negative. Okay, if you notice, this is our graph, where this one is cutting positive, and then it's cutting below the x-axis, because again, that's why C is negative. M is negative, C is negative, like that. It's cutting below the graph, below the x-axis, and it's also cutting, the graph is also pointing downwards, and m is negative, but c is positive. Notice where it's cutting me, and the graph is still pointing downwards. Okay, so these are all the cases for the line graphs that you'll need to remember, and exactly what the equation y equals to mx plus c will mean. So the m indicates the slope, whether it's positive and negative, will tell you how it's looking, whether it's facing upwards or it's facing downwards. And then the c tells you whether it's cutting above or below the x-axis. So if it's positive, it's cutting above the x-axis, and if it's negative, it's cutting below the x-axis, which is what is shown by the 4 graphs below there. And again, what else do we need to know about this? I think that's essentially it. There's 2 transformations from the f of x equals to x to getting the mx plus the c. Okay, thank you very much, ladies and gentlemen. We'll proceed again with the other graphs in the next video.